So today, lesson 11A. Today we officially start solving 8th grade equations. And the first part of that is solving multi-step. Anytime you have an equation where you're doing more than 2 steps, technically it's multi-step. This just really extends out from things that we were doing in pre-unit 1, where we may have had to use the distributive property. So today, solving multi-step equations by combining like terms and using the distributive property. I'm also going to show you checking, and that's one thing that I know for a fact that not very many of you do. At least plug your answer in and see if it makes sense. And, all right, so let's go ahead and get started. So we reviewed from 7th grade, combining like terms, so that when we got to today, it shouldn't be a big deal. And remember, all combining like terms means you gather the things that are alike. Like in this case, you can gather some x's together. And it shouldn't matter whether the terms are positive or negative, because the idea of negative numbers is from 7th grade. It's all the same idea, even if we're dealing with fractions and decimals, which is, for a few of you, the big killer. Shouldn't matter, though. We're still just combining like things together. And so we have to use that same sort of thinking today. Okay? And then sometimes when we're solving equations, the solution is not an integer. And in a case like that, we could either leave it as 29/4 as long as it's reduced, or convert it to a mixed number. And for that matter, you could convert it to a decimal if you wanted to, but there's no need to. All right, first official new problem. Any ideas on what we should maybe do first? Yes? Yeah, so we're just combining like terms first. And I don't know what I just did there. I didn't mean to do that, so let me go back here.
What is that?
All right, so we combine the 4x and the negative 2x, because technically that is a negative 2x. If you add the opposite, you would see that it's a negative 2x. And that takes us down to a 2-step equation. And really, that's the idea, no matter how complicated the equation is. We want to get this thing down, and all multi-step equations down to a 2-step equation, because solving a 2-step equation should be easy. And of course, we should subtract 7 from both sides, and I clicked on it again. I'll just have you go ahead and finish it while I'm fixing my mistake again. It's tiles. Sometimes if students are struggling with basics, I'll go to there and show it with tiles, but we've done enough 2-step equations where that shouldn't be a big deal. All right, subtract 7 from both sides, then divide both sides by 2, and the solution is x equals 6. All right. Everybody go ahead and do number 1. Up here, Dominic, use the sentence frame, please. All right, so the solution is x equals 5. So combine like terms. Then we have a 2-step equation. Subtract 6 from both sides, and then divide both sides by 3, and we do get a solution of x equals 5. Remember, you could check to see if it's a solution, which is where we actually, the next to last lesson of Unit 1, we were talking about the idea of solutions, and that just means you're trying to find something that makes a true statement. So if I plug 5 in for x, we can see that, yeah, it is a solution. And it shouldn't matter whether the coefficients are integers or decimals. We're doing the same thing. So could I have everybody do number 2? All right, so we combine like terms. We have a 1.5x, a positive 1.5x, and a negative 1x. That is positive 0.5x. Now we have this down to a 2-step equation, sorry. We need to add 7 to both sides, and this is what I was talking about. That division of 25 divided by 0.5 is from 5th grade. So if you've forgotten how to do that, it goes like this. 25 divided by 0.5. We have to divide by a whole number, so we would have to move that decimal one place to the right. And so what I teach 7th graders is to rewrite it before you do your division, but you also have to do the same thing here, move it once. So that number is technically now a 250. So once again, I have the 7th graders rewrite before they even start doing their division so they don't mess up on where the decimal's supposed to be. And plus, look, can't we at that point do it in our head? Yeah. Yes? 50. What's 250 divided by 5? 50. It's 50, yes. So the solution is, let me take that off there, x equals 50. And we could check. I'm not saying we have to every time, but there's no excuse for getting an incorrect solution because you could check to see whether you're doing it right or wrong. Then we have number 3. All right, so I'm going to show you something, but I need you to fully understand why we can do this and when you should do this. So don't start solving it yet. I know from experience, especially when you're solving equations, most students don't like dealing with fractions. And there is a property that we already talked about in pre-Unit 1. It's called the multiplication property of equality. And it says this, that you can multiply the equation by anything that you want to as long as you multiply everything in the equation by that. So what I'm saying is this. We can get rid of all the fractions in that equation if we multiply everything by the same thing. That's called, once again, the multiplication property of equality. And the thing that you would want to multiply by would be the common denominator. Now, this is almost a silly question. But what is the common denominator in this problem? 2. It's 2. There's only one denominator. So watch. If you multiply, and you have to multiply everything by 2. So 2 times this, 2 times this, 2 times this, 2 times this. The common mistake that people make, once I show you this little, and some people think of it as a trick. It's not really a trick. Once again, you're using a property of math, so it's not a trick. But they won't multiply everything by the common denominator. So now look at what we have. 18 equals, what's 3 halves y times 2?
6 halves.
What is it?
6 halves.
But what's 6 halves?
3 halves.
No, it's, yeah, thank you. It's 3y. Okay, because you could have done this. Plus 6 minus 4y. Now, do you agree that that is easier to deal with than the original equation? They are equivalent to each other. I simply multiplied everything by the same value to change the look of it. But they're identical to each other. You can always do that. Now, I'll talk about in some problems how you have to do something else first, but go ahead and finish that one. So I accidentally took off everything, so let me do this again. Multiplying everything by the common denominator. We have 18 equals 3y plus 6 minus 4y. Combine like terms, so I have negative 1y plus 6 equals 18, and I'm just going to leave it in that order. I know some of you rewrite it, and that's fine. So now I have 12 equals negative 1y. Divide both sides by negative 1, and the solution is y equals negative 12. Okay? If you had left it alone, you'll get the same thing. Watch. I'll go ahead and combine like terms right there. And I still have a fraction in there. Subtract 3 from both sides. And then I have to divide both sides by negative 1/2 or multiply both sides by negative 2. So you'll still get there. It's just that we can get rid of the fractions from the very beginning and then not have to worry about it again. Okay? And we could check. We don't need to, but you could. Okay? All right. I'm going to go ahead and have everybody try number 4. So I had mentioned something about you can get rid of decimals within equations as well, but I don't think that makes this one any easier. In fact, I think it makes it harder. We'll do that in another problem. So that's why I didn't mention it in this one. I would just leave it alone. Because sometimes it is easier to just leave it alone. So we've got a 1W there and a negative 2W. When you combine those like terms, you have negative 1W or negative W. So we have negative 1 equals negative W plus 0.5. Subtract 0.25. Subtract 0.25 from both sides. On the left, we now have negative 1.25. On the right, we technically have negative 1W. Divide both sides by negative 1. And W is 1.25. So the solution is 1.25. And once again, we could check by plugging in 1.25 for W and seeing if it makes a true statement. And of course, it does. All right. Sometimes, as we already know from earlier problems, we need to use the distributive property. So all of you should know how to do this one and number 5. So can you go ahead and do this one and number 5 for me, please? So we use the distributive property. Now we have a two-step equation. Add 12 to both sides, then divide both sides by 6. I also asked you to do this one. What was the solution to this one? M equals? 8. All right, so use the distributive property. Remember, you could put the 4 times the quantity m minus 4 on the left and the 16 on the right if you wanted to. But at that point, we add 16 to both sides and then divide both sides by 4. All right, so m is certainly equal to 8. All right, sometimes, like in number 6, we have to use the distributive property and combine like terms. So can I get all of you to just do the distributive property first and then stop? All right, so you use the distributive property. We get 0.3 times x, that's 0.3x. And hopefully nobody made a mistake on the 0.3 times 12, because that's 3.6. Okay? Now, just like with equations with fractions in them, you can get rid of decimals within a problem. Okay? So listen carefully. But in order to do either one of these things, if you have an equation that involves the distributive property, you got to do the distributive property first. Are we clear on that? Yeah. That's why I didn't talk about it before this. So could anybody think of something that you could multiply everything in that equation by so that you would no longer have any decimals? It would be 10. And anytime you have decimals, it's either going to be 10 or 100 or 1,000 or something like that. So let's go ahead and do that. But remember, we have to multiply everything by 10, not just the decimals. That's what makes it the multiplication property of equality. Okay? So now, 10 times 0.3x is 3x. 3.6 times 10 is 36. Negative 1x times 10 is negative 10x. And 0.1 times 10 is 1. Now, remember, you may have thought that the previous step, you could have just solved it that way and everything would have been okay. And some people just leave it alone and just deal with it. But if you don't like to deal with equations with decimals, this is one thing that you could do. Because many of you might think that that looks better, that looks easier. But that's entirely up to you. That's your choice. Okay? So from here we would combine like terms. Subtract 36 from both sides, because at that point it should be easy. 1 minus 36 is negative 35. Divide both sides by negative 7, and the solution is x equals positive 5. Okay? Now we're going to do the same sort of idea in number 7. But before we can, and then notice up here, I just leave it alone because obviously you're going to get the same thing, but you don't have to worry about adding decimals. You don't have to worry about dividing by decimals. All right, so we're going to do the same thing in number 7, but remember, before you can multiply everything by the common denominator, you have to get rid of or use the distributive property first. So could I have all of you go ahead and do the distributive property? This times this is negative 5k. This times this is plus 15 plus 1 equals 1/2. Now, some of you might think, well, I'll just deal with it the way that it is. But let's pretend for a second that you want to get rid of the fractions in that problem. What would you have to multiply everything by? Somebody tell me. What is the common denominator? It's 2. But remember, we have to multiply everything by 2. And once again, that's not a trick. It's the multiplication property of equality, which says you can multiply both sides of the equation by anything you want, as long as you multiply both sides by the same thing. So now I'm going to let you go ahead and finish that problem. So finishing this off, I have negative 10k plus 30 plus 2 equals 1, which is negative 10k plus 32 equals 1. Subtract 32 from both sides. 1 minus 32 is negative 31. And it's your choice whether you want to write the solution as 3.1 or 3 1/10 or 31 over 10. My open math will take any one of those because 3.1 is equivalent to 3 1/10, which is also equivalent to 31 over 10. Okay? All right. Last idea for today. So before we can get into this last type of equation, we have to make sure that we understand, because sometimes, especially with fractions, people start learning shorter ways of doing things and skipping steps, and they forget the very basics. So, negative 3/7 plus 12/7. That is equivalent to, and this is where you start writing, negative 3 plus 12 all over 7. Usually when people are doing fraction problems, they skip that step right there. But you need to remember that those two things are equivalent to each other. We all know that, right? Yeah. All right. Negative 5, or not negative 5, 5 plus negative 11 all over 9 is equivalent to 5 over 9 plus negative 11 over 9. You should be adding these to your notes. And so if we had like 5 plus w over 9, that is equivalent to 5 over 9 plus w over 9. Now, we had to quickly review that so that we could solve those last two types of equations. Okay? So, when you're dealing with this right here, this is the way that I recommend that you do these. You first of all think about what this is equivalent to. And this is equivalent to 6 over 5 plus h over 5 equals negative 9. Are we all good with that? Yeah. All right. So now you could subtract 6/5 from both sides, or you could multiply everything by the common denominator. What's the common denominator? All right, you go ahead and finish it, and then also do number 9. All right, so common denominator here, if we're going to do it that way, is 5. So we're going to multiply each thing by 5. You have to multiply everything by 5. And the common mistake is to not multiply the negative 9 by 5, but you have to multiply everything by 5. So look, if you want to think of it this way, 5 is 5 over 1, and you have a fraction times a fraction. So 5 times 6/5 is 6. Most of you understand that in your head. What's h over 5 times 5?
1.
It's not 1. Let me try that again. What is h over 5 times 5?
It's just h.
It's just h. Once again, just like in the previous one, if it makes you feel better, make the 5 over 1, and you can do some cross-dividing. And you have 1h over 1, which is just h. And then, of course, negative 9 times 5 is negative 45. And then subtract 6 from both sides, and h is negative 51. Any questions about number 8? Are we good with that? Okay. Because I'm going to take all this off. All right. So let's now go to number 9. Same idea. You want to first of all think of the right-hand side as w over 2 minus 6 over 2. Okay? Now, some of you didn't even realize that 6 over 2 is what? It's 3. Now, if you didn't, it's not a big deal. The common denominator is 2, so we're going to multiply everything by 2. And so negative 4.5 times 2 is negative 9. Didn't mean to write that. And once again, if it makes you feel better, put a 1 underneath of each of the 2's, and W over 2 times 2 over 1. You can do some cross-dividing, but that should be W. And then again, and you can clearly see the reason why we're doing this is so that we don't have any more fractions. And then at that point, add 6. And so it looks like the solution is W equals negative 3. All right, so we are finished. You know where the homework is.